I know, yeah.
Oh, yeah.
Okay, so in section 13.4, we are doing something called the cross product. Okay, and so when we're doing the cross product, it involves doing the determinant of a 2x2 matrix. And so if you remember that to do that, you do crisscross. You multiply and then do the and then subtract, right? So you do this guy 10 minus that guy. Now be careful, that's a negative 3, right? So 10 minus negative 3 would be 13. Okay. All right. So when we're going to do the cross product, it's going to involve a little bit of a bunch of these little pieces here. So I'm just going to teach you this one way to do it that is pretty much faster. So the cross product is going to give you another vector. When you do the cross product of two things, it's a vector for an answer. Okay? It's important to know how to do the cross product. It comes up a lot in the next section, how to do the planes, equations of planes, things like that. So you put ijk, and it's also important the order. You have this vector first, so you list that next underneath, so 2, negative 1, 3. And then underneath that, the negative 4, 0, 1. You put determinant bars around it, and then we're going to do our work. So, if you want to, you're going to get a third vector. So, it comes out to a vector for an answer. So basically what you do is you kind of in your mind cover up the first column. You cover up the I column. So you cover up the I column and basically the I row. That's going to get you the answer for I. So what's the determinant of those four numbers left over? Negative 1 minus nothing, so negative 1. So you just keep doing that. Right, negative 1 minus nothing. Alright, now do the center. So when you're doing the J, you cross off the J column and you do those four numbers left over. So that's going to be the most annoying one, but there's also another trick to that J part. So when you do that, you get 2 minus negative 12, so you get 14. But for the middle one, you have to remember to change the sign. So later you'll learn that in linear algebra, but the middle one for now, you just change it. So whatever you get, it's the opposite of that. So you got 14, you change it to a negative 14. Your negative, change it to a positive. The middle one is opposite. And then the last thing, so I'm covering up the K. What's my determinant of those four numbers?
Negative 4.
0 minus 4, yes, so negative 4. And it doesn't always turn out negative. It doesn't, it's all negative. It just so happens here. Okay, so you get a third vector. Now, this third vector, let me tell you, is special because this third vector is actually perpendicular to the original two. So, how do I prove to you that this vector is perpendicular to each of those? I should do their dot product. So, if I do 2, negative 1, 3, and I dot that with my negative 1, negative 14, and negative 4, it should come out to 0. So I get negative 2 plus 14 and minus 12. So it is. Okay? And then if we try the other one, you don't believe me, negative 4, 0, 1, dotted with my negative 1, negative 14, negative 4. So that comes out to 4, 0, and negative 4. So that's also 0. So this produces a third vector. This right here, it's perpendicular to both the original. So later, when you're trying to do equations of planes, this is important because when you have a plane, the surface of a plane, like the direction of a plane. The direction of a plane, you might be like, oh, let me just like have a vector on the plane, right? Like my plane, like it's going like this. Let me just have a thing on that. What about that direction? I'll just use the direction of this. Well, how do you think if I hold this stick in the same place, can't the plane be like here, here? Like it could be anywhere, couldn't it? Yes. Like that direction of that plane, just because you're like, oh, this line is on the plane, so what? Like the plane could be slanted any which way. I can hold this straight. But if you use two vectors on the plane, if I use two vectors on the plane and I find their cross product, something perpendicular to them, there's only one thing that's perpendicular to this stick, and it goes in that direction. You know what I mean? So, like, if these are on the plane and I do their cross product, it finds me another vector perpendicular to them, and that only fits against here at a 90-degree angle one way. If I turn it, it's like not 90 degrees anymore. You see what I'm saying? So the direction of a plane is not something on it. The direction of a plane that you use is actually something perpendicular to the plane. Follow? And you find the direction of a plane by knowing what's perpendicular to it, and you find what's perpendicular to it by the cross product. Look at that, I got to use the teacher's stick. Okay, so that's not for now, but that's like next time when I start explaining that, you're like, oh, okay. Okay, so next page. Alright, what's the difference between A cross B and B cross A? They are opposites of each other. So they are opposites. I think this is recording this page, but I don't know. So, opposites. So if I would have like reversed the order on that other thing, I would have gotten, instead of all negatives, I would have gotten all positives. They would be opposite directions. And so you do have to do it in the order you're asked. You can't just like put it up there and like no matter what, like do it in the order you want. You have to do it the way it says. Okay? But when you're choosing to do it for a plane equation, you can do it whatever way you want. But when somebody asks you a specific order, you do it that way. All right, so some useful formulas that you can do. So it just so happens that what do these bars mean right here on number one? The magnitude. If you do the magnitude of the cross products is equal to multiplying the magnitudes times the sign. So this is another way, a worse way, but this is another formula for finding the what between two vectors. The angle between two vectors. All right. So the angle between A and B, you could do this formula if you want, but would you rather do the cross product or the dot product? Really?
I don't know.
The cross product is what we just did. It takes a minute. It takes a while to do it. Dot product, the cosine formula that you've been using, cosine equals A dot B, right? Dot product's like so fast. Like you never use this because it's a pain in the butt. Okay? So the ones that we kind of do use are more like these two right here. So like I would write these down on my note card or whatever. The magnitude of the cross product is also the area of a parallelogram with A and B as two of its sides. So if you take vector A and vector B and like line them up, and if you complete a little parallelogram with that, the magnitude of A cross B is the area of that parallelogram. That's just a thing. All right. If I take half a parallelogram, what does that turn into? If I cut half of that off, it turns into a triangle. So if I take half of that area, it's the area of a triangle. With vectors A and B as two of its sides. All right, let's play for a second. Hello. So, if the cross product equals 0, I forgot, then that's another way to prove your vectors are parallel. So, if you want to, but who the heck wants to do a cross product just for fun? Nobody. It's a lot easier to tell me that something's parallel if you can recognize they're multiples of each other. Like, oh, this one's double that one, or whatever. Like, this would be like kind of like a long way to go. Okay. And there's just some rules about theorems and rules on page 826. Maybe just look over those a little bit. I was trying to make a star, but it doesn't work that good. All right. So there is something called a triple product. So let's see. A triple product. So it's also called a scalar triple product. And let me move this little thing right here. This little shape, I bet you didn't know. This is called a parallelepiped. A parallelepiped. Right? So it's like a rectangular prism, but it's like slanted. Right? Okay? Parallelepiped. I think I'm saying it right. Look it up on like Khan Academy. The guy will say it in his British accent. Parallelepiped. All right. Say it 3 times fast. Parallelepiped, parallelepiped. Okay, so a parallelepiped is like a rectangular prism, but you know somebody's like squished it over. But if you have vector A, B, and C are its 3 sides, like its corners, all right, and then you know they're together at the origin and whatnot. If you want to find the volume of this thing, because now it's a 3D shape, the volume of this thing is going to be this formula. The volume is the magnitude or the absolute value, but we'll talk about it in a second. Just write it down. A dot and then B cross C. Alright, so let's think about, we know the volume is going to be like a single number, right? It's not going to be another vector. So think about this. B cross C produces what kind of problem? Or what kind of, a vector. You have a vector dotted with another vector. So that's going to produce a number, like a scalar. So do these bars, do they mean magnitude or do they mean absolute value? Absolute value. Kind of mean absolute value. Because bars around a vector mean magnitude, right? Bars around a single number, like this is going to be a scalar. It's more like they mean absolute value. And we all know volume positive, right? Okay, so we have our example we're going to do here. So I want you to practice by finding me, so you do the hard part for me. Find me B cross C right now. So I need B cross C for this guy. So you find it.
Yes, you can indeed get that answer.
Right. Let's see. Did you get 7? 7, negative 4, and then what? 24? Okay. Everybody good? 7, negative 4, 24?
It's 4 times 1.
Who's asking? Yeah, sure. Alright, so we just have to dot that with A. So if we dot that with A, we get negative 14. Right? Negative 2 times 7, negative 14, plus we get negative 12, plus 0. Is that good? Absolute value of that?
28.
26. 26. Yes, 26. So 26 units what? Volume, right?
26 meters.
No, it's not meters, Nathan. No. If you put M, I'm going to take a point off on your quiz. I will. You have to put UN, units.
Yeah, I thought it was 4.
What happened?
Wait, how is that 4?
Okay, so B cross C, I got 4, 1, negative 1.
Centimeters squared? Oh, yeah.
Yes, okay. So, yeah, so we got 4 minus nothing. Everybody good? Okay.
20.
That
says 26 universes cubed.
Alright, so then of course there's some little physics formulas and whatnot. So there's something in physics called torque, alright? So one use of cross products is in torque. So you have like somebody like with a little wrench right here, right? And you're pushing down on the wrench to like, that's your force because you're pushing on it. You're pushing on it with a certain angle, okay? And this R right here, that's like your axis that you're pushing off of, right? And so if you know these, if you knew the R vector and your force vector, I'm sorry, this R right here. If you knew R and this force vector, then you could do their cross product, and that would be your torque. But a lot of times you don't know that. Sometimes you know, like the magnitude of each one, like you know how strongly you're pushing, you know the angle you're pushing at, and like you know the magnitude or the length of your because the magnitude of R, that'll be the length of the wrench, right? So those are more things that you kind of like know, like, oh, I can measure the wrench, I can know how strong I am, I know what angle I'm pushing at. So it just so happens if you knew the actual vectors, you could do their cross product. But then this is like more useful because then it's like things that you know. And you remember earlier, that was like a formula from that sine formula. Remember, if you're on like, do you want to do the dot product or the cross product? If you divide these two under there, that's that formula from earlier, right? Sine theta equals the cross product over the other two. This comes from earlier. Yes.
So for the question at the bottom when it says so like a 0.25 meter wrench.
Yes.
So that's the magnitude of the
That is magnitude of R.
Okay.
So that's like the length of the vector you're trying to push on. All right. So yes, this guy is R. She's telling me to shut up for explaining and just get to the problem. I'm teasing. Like, okay, whatever, just you know. All right, that's your F right there. All right. So then what's my angle in my picture? 75. All right. So your magnitude of your torque right there is going to be your 40 times your 0.25 times the sine of your 75. And of course, make sure your calculator is in degrees, and you get 9.6 Newton dot meters, you could say. Is that joules? Right. A lot of times also torque is in foot pounds, but that's not these because you push with a certain amount of pounds of force, you know, and you're pushing a certain amount of feet. So a lot of times it's foot pounds, but this one isn't. Okay, so I am over class today because of my computer and I need to get that fixed. So here's your homework. I will also probably put a 15-minute video of the beginning of 13.5, like maybe 10, because you gotta also make your little note cards. So I'll do 10 minutes, and I'll try to go slower. Alex said you're talking too fast, so I'll try to finish. And so I'll do like a nice slow 10 minutes, all right? And then finish this 13.4. And if you want a note card for your quiz, then I will. I have to go to
I don't even know how.
the other one to work.
Is this true?
If you don't put uniform Alright, if you guys want a note card, if you don't have one, I'll put them on Joanne's desk. If you want to take a note card, if you want one.
Hey, you just actually got another book. No, it wasn't like, it didn't die naturally. My dog got, I swear it's something like flushing out.
So yeah, your quiz is 13.1 to 13.4. Okay, good. So 4 of them came in, and then I'm still waiting. So they're trickling in. So I just gave it to these 4, and then sorry, you can catch it next when the next one comes. They're all from different people. Like it was like random people on Amazon selling bookstores.